So once again, I'm explaining how things are. So I measured the piston protrusion above the cylinder block. On one side it's 0.8 mm. On the other side it's 0.75 mm. That is from the first to the third it's 0.75. From the fourth to the sixth it's 0.8. So we won't pay much attention to this 0.05 mm. That means we'll be removing about 0.35 mm from each piston. That's 3.5 tenths give or take. So I definitely won't be doing it on my own machine because I tried. I just don't have the capability. The machine is very old and the tool holder is completely jammed. So it comes out with the nut in one direction and it doesn't move at all in the other direction. Basically it's impossible to do this on my lathe. So what did I do? I made a fixture like this out of a sleeve. I took an old sleeve and basically turned it into a regular cylinder on the outside. I didn't do anything to the inside, just cleaned up the outside. And then I simply made a cut like this with an angle grinder. When I made the cut in the sleeve with the angle grinder, it tightened up a bit on its own. So now this fixture holds the piston tightly. If you want to put it on, you need to spread it a little like this. That way it goes on and comes off easily. And you just clamp it a little in the machine and everything is perfect. I already tried it. I clamped it in the lathe and measured the runout with this dial indicator. Everything turned out well for me. There was only 0.03 of a millimeter of piston runout set up with the dial indicator. Now I just need to remove about 0.35 millimeters, but I can't do that because I'm afraid I might not hit the right size and could take off too much. So I've already made arrangements with the lathe operator, but today he's not working because we have this coronavirus situation again, another lockdown and so on. So the lathe operator isn't working today. We've agreed to do it tomorrow. So tomorrow during the day he'll machine the pistons. Here's what I want to say. It turns out that on Friday I positioned the crankshaft and took measurements. I measured one piston on Friday. I also came in on Saturday. I made the remaining measurements on both sides here, likely while working on something else. I was here again Saturday and yesterday was Sunday. I didn't go to work at all. Well, because there was no point. I didn't go to work. So today is Monday. We just found a machinist and I made the mandrel. Tomorrow, Tuesday, will be lost to work. Taking it there, machining it, bringing it back and so on. So why am I saying all this? So it turns out Saturday, Sunday, Monday and Tuesday. I've lost 4 days again because of these pistons. That's why my repair is taking so long. Yeah, I think it will be at least 2 months, definitely not less. So if by the beginning of December he leaves here from the shop, that would be good, because just on the machining work alone we've lost almost, I just counted, well, practically 23 or 24 days. If we take away all those days, then I've only actually spent about 10 days working on this engine. That includes disassembly, cleaning and so on. Alright, that means the pistons are going to the lathe now. And now we wait again. So it's Wednesday morning here. The pistons have come back from the lathe. They've machined the piston crowns and removed about 0.30 to 0.35 millimeters. Well, basically the machining quality suits me just fine. We'll check the size against the cylinder liner. When we install the piston into the cylinder sleeve, we'll also measure how much the piston protrudes above the cylinder block. That's it. I'm attaching pistons to the connecting rods and installing piston rings. Everything is nearly ready and the bearings are in place. So I also gave the machinist my dial indicator with a magnetic holder. I also gave him my hammer to tap the pistons a bit in the fixture. Well, I don't think he used it because when I tried it myself on the lathe, I could literally adjust it by hand. So I also gave him an old piston for practice, so to speak. We can see that the machinist tried different cutter, apparently from the cutter differently, meaning he was adjusting the machining speed. I also gave him these round nose pliers. As I showed, the mandrel fits very tightly. I gave him these round nose pliers and he made these holes here. And this way you can loosen it, here it gets fixed and then the piston can be easily removed and inserted. That's it. Let's get to work. So I installed the piston rings and the bearing shells. Before putting the rings on the piston, I measured the ring end gap. I've already installed 3 pistons, the first, second and third. And now I want to show on camera the piston protrusion above the cylinder block. So I supported the third sleeve. We're turning it just roughly by eye for now. So here we have the top dead center. We can see the block, that's our 0 point. Looking at the piston is about 0.445 millimeters, 45 or 46. Well, if we measure at the top, it shows about 48 or 49, so at the bottom it will be a bit less. At the bottom it shows 43, so the piston moves a little there. Let's measure again in the plane of the piston pin. Yes, 46 or 47. From the other side, yeah, also 46 or 40. That means everything is great. Right now, the protrusion of this piston is about 0.46 millimeters. Well, let's say roughly 4.5 tenths above the cylinder block. The protrusion is allowed up to 0.61 and the minimum is, I think, 0.27. So with this piston everything is fine. Well, I've already checked all the pistons. Everything is fine. Now I'll show the second piston on camera as well. Alright, so the second piston has reached top dead center, and let's see in the plane of the pin it's showing 46, 47. Looking from the second one, well, it's showing somewhere around 47, 48, 48 hundredths. Alright, so let's see, the block is at 0, we move to the piston and we see it's showing 41, 42, something like that. Obviously, it's impossible to get it exactly to the 100, so this piston is 4 hundredths lower. It's clear that measuring exactly to the 100th is impossible. There will always be some discrepancy. I thought the discrepancy would be about a tenth, but so far we only have a discrepancy of about 4 or 5 hundredths on this side. Now, we'll measure the other side as well. So, I'll explain in a few words. I made this kind of jig from an old cylinder liner, but I'm not doing a very good job installing these pistons in particular. Why is that? Here we have a very thin oil control ring. It's just extremely thin, very delicate, and how should I put it? Its spring pushes out really strongly. So I end up with a taper, and this ring binds up on itself, meaning it goes onto the piston like this, and the taper starts to compress it, but its inner edge is already pressing against the piston itself. That's why it doesn't work out for me in this case. That's why I have to assemble the engine with this tool. Even though I usually use those kinds of tools all the time, in this case I'm using this expandable universal one. It turns out the piston protrusion is the largest on the 4th and 5th cylinders. is 0.51 millimeters, that is 51 hundredths. The smallest piston protrusion is on the first cylinder. There we had 0.42, so the difference is about 1/10, somewhere around 9 or 10 hundredths, that is 1/10. Well, basically that's what I expected, because it's very hard to get a precise size on a lathe, at least in my experience. Everything is fine now and within the normal range. So the pistons are installed. I checked how the injector fits into each piston, everything is fine. There's enough clearance everywhere, nothing is hitting. I also tightened the connecting rod bolts to 120 Newton meters, the marks are across. Turn them another 90 degrees so the marks are along. Check to make sure each connecting rod moves freely. The crankshaft itself also moves. There's some axial play. So what's next? Now I'll install the counterweights, tighten the 4 counterweights, then I'll put the camshaft, the timing gear, close the rear cover and close the front cover. So I'm closing the flywheel housing. Let's check the timing marks once more. I also want to show the gaskets. The gaskets are metal asbestos 0.75 mm thick. Gasket thickness impacts camshaft axial movement. Here we have a thrust ring, a thrust plate on the flywheel housing, and if you use a thinner gasket, it will clamp it. If you use a thicker gasket, it will start to have play. So I installed the housing and immediately installed the flywheel. My flywheel is already prepared and we're keeping the old flywheel. So as we remember, one of the supports for the cushion has a crack. Here's the crack, and it's already more than halfway through. So we got another one, a used one, exactly the same. I'm taking this one off now and installing the new one. I've installed the flywheel housing and front cover, tightened everything. Now I'll explain my next steps. Since my oil pan is not original, I won't risk installing it right now. When I flip the engine over, all the weight ends up on the corner of that pan. I'm not saying it's gonna crack or that it won't hold up or anything like that. I just want to play it safe, that's all. I'm double checking again to make sure everything is tightened. My main bearing bolts are tightened, my connecting rods are tightened, and my counterweights are tightened. I'm also checking that my caps match up. Numbers 1, 2, 3, 4. I'm also making sure that my connecting rod and the connecting rod cap match as well. 106, 150, 160. Yeah. 161, 161, 156, 156, 167, 160, 163, 163. Well, basically that's it. I'm just going over everything one more time to make sure everything is okay, nothing has fallen and so on. Now I turn it over, and as I said, I installed the oil pump and the oil pan in the inverted position. I've turned the engine over and I'm starting to install the oil pump. The old oil pump was rejected due to internal wear and scratches after opening the cover. I've already removed the pickup and prepared it. Here's our new pump. It's unpacked now, and we can also see it's a 43. So we'll also have a new pressure relief valve. As you can see, the manufacturer is Mercedes, so the relief valve will be original. I've installed the oil pump, tightened it, and now I'm installing the oil pan. The oil pan is new. In one of the episodes I showed how I unpacked it, explained the reasons why we have a new oil pan and so on. I installed a new gasket, also cleaned the bolts. The bolts were all covered in sealant, both the heads and the threads were in sealant. I unscrewed the drain plug, annealed the copper washer, reinstalled and tightened it. The oil pan was clean, so I blew it out, degreased everything, and now we're installing it. So I turned the engine over the day before yesterday. I turned the engine over. Yesterday I didn't remove anything. I was taking things off. There were 4 shelves of unwashed parts on the rack. Yesterday I spent the day washing, cleaning, blowing everything out and so on. So today I prepared the heat exchanger. I removed the heat exchanger core, washed it with diesel fuel in the parts washer, then with solvent and so on. I washed the air conditioner compressor, cleaned the alternator and got everything ready. It's still on the rack, including the filter. So the air conditioner compressor is not used. It doesn't work. It's just there as an intermediate part. I'll install the heat exchanger, put in the fuel equipment, and lay out the pipes here. So what else happened yesterday? What problem did we have? I took out this gasket, and we can see that right here. We have a chip, yeah, exactly where the gasket sits. A piece just broke off, yeah? To install it before. Instead, there's no way to use the cover anymore because, well, the gasket won't be pressed properly. So either get a new cover like this or maybe find another cover. So once again we have a small problem with this engine. Well, when I was taking it apart, I didn't see it because everything was dirty, covered in oil and so on. There was a gasket here, so there was dirt on both sides. Nothing was visible. And only when I took out the gasket did I see this situation. Again, we have this kind of delay, so to speak, with this cover, and it's not clear when it will show up. Alright, let's start. I'll assemble and comment on some things, others I'll just put together. Let's go. Next, I'm installing the individual PDL pump section. We had the fuel injection equipment checked, and they said it's basically in working condition, so the fuel injection equipment is fine. I'm not doing anything special, just installing them in their places. I have a mark for each one. So I replaced the rubber seals with new ones. The old Erling brand seals were different. There's really no need to install them all. I just oil and install them. So next I'm assembling the compressor. Everything is already prepared. I showed all of this in previous episode. Now, I've installed new rings and put the piston into the cylinder. Another point about the connecting rod. I mentioned that it would be new, but I unpacked it. So back then I had a new connecting rod. I unpacked it, but it turned out that this one is 19 millimeters and that one was 15 millimeters. We returned it and ordered from another company, but still got a narrow connecting rod, so we returned it again. We ordered the original by its Mercedes number, but every connecting rod is narrow. It feels like it's made for a 2-cylinder compressor, so maybe they don't even make a 1-cylinder compressor anymore. So we decided to keep the old connecting rod. I cleaned it. I measured the connecting rod as mentioned. Some people were concerned I installed the crankshaft without the connecting rod, meaning I'd need to remove the crankshaft. I want to say, you guys didn't need to worry. Now I'll show you how to install the connecting rod. I've installed some things, but still need to install a few more. I also need the cover here for the tubes, among other items. I'm showing you. For now, I'll start installing the cylinder head. But before putting on the heads, I need to install the lifters. The lifters, we have new ones from a new brand. And I also want to say that the only good thing about this block is this lifter keyway. That is, it's not worn out, it's absolutely perfect. So the connecting rod So I've prepared the bolts, washed them, cleaned them with a wire brush, and I want to respond to two of the most popular comments that are always there and always will be, I think, under this video. The first one I read is that the length of the new bolts rod is 210 mm. Next, the allowable length of the rod is 212 mm. That means the bolts can be reused if their length does not exceed 212 mm. We take the bolt, take a ruler, put it next to it and check. The length of this bolt is 210 and a couple more tenths. So this bolt can still be used a few more times as long as its length doesn't reach 212 millimeters, as long as it doesn't stretch, as long as it doesn't get longer, as long as the metal doesn't start to flow. It can be used up to 212 millimeters. It can be reused multiple times. You can tighten, remove and retighten it repeatedly. So I think I've answered the question about reusing bolts. So now let's look at another point. Let's read it. Lubricate the contact surface, the thread and the shank of the cylinder head bolts with oil. I think that's clear too, right? The contact surface and the thread as well. A very popular comment is, why are you using oil? That's wrong. The torque spec changes and so on. So I hope I've answered the most common questions. Now we're gathering smart people.